Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Our today's topic is phase and phase difference in a wave. वेव्स में फेज और फेज डिफरेंस की इंपॉर्टेंस क्या है, इसको हम इस टॉपिक में डिस्कस करेंगे। प्रीवियस टॉपिक में हम लोग वेव्स और उसकी टाइप्स और उसकी प्रॉपर्टीज, जिसमें वेवलेंथ, क्रस्ट, ट्रफ, एम्पलीट्यूड, डिस्प्लेसमेंट और फ्रीक्वेंसी, टाइम पीरियड डिस्कस कर चुके हैं। So before going to start phase and phase difference, there is a relationship between velocity, frequency, and wavelength of waves. So to drive the relationship between these three quantities, let me consider a wave that travels a distance equal to one wavelength lambda in its period t. Then velocity of the wave can be determined by using an equation. So this is the wave, and it travels a distance equal to one wavelength from crust to second crust. This distance is equal to one wavelength, or it is represented by lambda. So let me suppose this wave travels a distance equal to one wavelength lambda in its period t. So the relationship between speed, frequency, and wavelength can be determined by using equation S is equal to Vt, where V is equal to S over T. S is distance covered, T is the time taken. And here distance covered is equal to one wavelength represented by lambda, and the time taken is equal to capital T. So by putting both values in above equation, the speed of the wave becomes equal to lambda over T, where 1 over T can be replaced with frequency. So V is equal to F lambda. This is relationship between velocity, frequency, and wavelength. And from this equation, we can describe that frequency and wavelength, they are inversely proportional to each other. So if there is a wave with less or short wavelength, then it will have greater frequency. But the wave with longer wavelength would have less frequency. So the product of frequency and wavelength is equal to V, that is velocity of the wave. So V is equal to F lambda. Now what is meant by phase? Phase से क्या मुराद है? So phase specifies the location of a point within a wave cycle of a repetitive waveform. कि एक वेव फॉर्म के अंदर फेज एक पॉइंट की लोकेशन को डिस्क्राइब करने में हेल्प करता है कि व्हाट इज द location of a point in a wave cycle, so it can be determined by using the phase. So phase is basically an angle, and it is measured in degrees or radian. For example, this is an oscillating sine wave, and this sine wave have different points. For example, this is the point. So phase of this wave at this point is 0 degree, and in radians it is also equal to 0. And at this point, the phase of this sine wave is 90 degree, and in radian it would be pi by 2. And at this point, the phase is 180 degree, and in radians it is pi. And this is the point where it has negative peak value. So its phase at this position is 270 degree, or it can be written as 3 pi by 2. जबकि यहाँ इस पॉइंट पर जो इसका फेज है उसको आप 360 डिग्री या फिर 2 पाई रेडियंस भी मेंशन कर सकते हैं. सो दीज पॉइंट्स हैव डिफरेंट फेज, and that is also called their absolute phase, कि हर पॉइंट की जो लोकेशन है उसको आप डिस्क्राइब कर सकते हैं with the help of this phase angle, which is different for different points. For example, let this is a particle. There is a black spot which is moving in a circle having some radius r. So there is another point which is also moving in the form of a sinusoidal trace. So we can compare the phase and the location of that point with the help of this diagram. आप नोट कर सकते हैं कि at this position there is 0 degree phase, then at this position there is 90 degree, 180, 270, and then 360 degree. So with this 360 degree angle, this phase changes. The location of the point also changes with respect to time. Now, what is phase difference? So phase difference between waves is important rather than the actual phases of the signals. यानी signals के एब्सोल्यूट फेज की निस्बत अगर हम फेज डिफरेंस के कंसेप्ट को सामने रखें तो वो ज्यादा इंपॉर्टेंस कहाँ मिले, उसको प्रेफरेंस दी जाएगी फेज डिफरेंस को. Suppose when two waves combine with each other, for example, the difference between the phases of two waves is important in determining the resultant waveform. कि जब आप दो वेव्स को कंबाइन करेंगे तो उससे हासिल होने वाली रिजल्टेंट वेव फॉर्म को डिस्क्राइब करने के लिए या उसको डिटरमिन करने के लिए आपको इनके इंडिविजुअल फेज को यूज करना पड़ता है. The phase difference between two waves having same frequency moving past a fixed location is given by the time difference between the same position within the वेव साइकिल्स ऑफ द टू सिग्नल्स. के अगर आप फेज डिफरेंस को मेजर करना चाहते हैं तो उसके लिए हमें उन सिग्नल्स के टाइम डिफरेंस को सामने रखना होगा. फॉर एग्जांपल, इन दिस वेव we can observe that there are two signals. One is representing with blue line and other one is representing with red line, and they are not in phase. They have some phase difference between them, and this phase difference can be determined by this time difference. What is time difference between them? So we can describe which one is leading and which one is lagging. तो जब आप टाइम डिफरेंस फाइंड करेंगे तो ये टाइम डिफरेंस दोनों सिग्नल्स के लिए हमें थ्रू आउट द टाइम सेम ऑब्जर्व करने को मिलेगा. So this is the importance of phase difference instead of their absolute phase. कि जो रिजल्ट आप किसी एक पर्टिकुलर पॉइंट पे हासिल करेंगे वही रिजल्ट आपको तमाम वेव पे अप्लाई करना होगा. Now what is meant by in phase? Two sound waves of the same frequency that are perfectly aligned have a phase difference of 0 and they are said to be in phase. कि अगर दो वेव्स को आप कंबाइन करते हो और दोनों ही सेम पोजीशंस को रिप्रेजेंट कर रही हैं, they have zero phase difference, so they are called in phase. So two waves that are in phase, when they are added, they will produce a sound wave, resultant wave, with an amplitude equal to sum of the amplitudes of the two waves. कि जिन दो वेव्स को आपने कंबाइन किया है उनके इंडिविजुअल एम्पलीट्यूड्स के सम के बराबर आपको रिजल्टेंट वेव का एम्पलीट्यूड मिलेगा. फॉर एग्जांपल, देयर आर टू वेव्स, वेव नंबर 1 इन ब्लू लाइन and wave number 2 which is represented by red one. So when they combine with each other, आप नोट कर सकते हैं कि where the crest of one wave falls, the crest of other wave also falls at the same point. So when these waves are combined, so crest of one wave falls on the crest of other wave and trough of one wave falls on the trough of other wave. So when they will combine, they will produce a resultant wave of greater amplitude. Their amplitude will become greater because they are supporting each other. So due to their supporting factors, the amplitude of the resultant wave increases. So this is the result when both waves are in phase. They have zero phase difference. There is no phase difference between these two signals. So that's why the resultant is equal to in the form of a wave with greater amplitude. But in case of out phase, if there are two waves and they have same frequency but they are shifted by one half cycle relative to other, कि जब एक वेव और दूसरी वेव में हाफ साइकिल का डिफरेंस हो, so they are called out of phase. For example, in this diagram आप नोट कर सकते हैं कि where the crest of one wave falls, at the same place there is trough of other wave. So when crest of one wave falls on the trough of other wave, then they will cancel out each other's effect. And due to this cancelling effect, the amplitude of the resultant wave becomes zero or minimum. So this is the resultant wave when these waves combine with each other. So crust falls on the trough. Similarly, trough of one wave falls on the crust of other wave. So they cancel out each other's effect and the amplitude of the resultant wave becomes zero. So such waves are called out phase or out of phase because they have phase difference between them. No, there is another term, phase lead and phase lag. So to understand this phase lead or phase lag, we have this waveform. There is a pattern where two waves are traveling in the same direction but with a phase difference. अब आप यहाँ पर note करेंगे कि which one is leading and which one is lagging. Suppose we have a source, suppose AC source है और उसकी frequency 50 hertz है. 50 hertz means 50 cycles are passing through a certain point in a 1 second. तो अगर एक ही सेकंड में 50 साइकिल्स पास हो रहे हैं और आप उसके हर पॉइंट के फेज को आप डिस्क्राइब करना चाहते हैं, सो इट इज वेरी डिफिकल्ट. लेकिन अगर आप फेज लीड या फेज लैग के कंसेप्ट को यूज करेंगे तो इसमें हमें किसी एक पर्टिकुलर पॉइंट पे रिजल्ट जो मिलेगा वही तमाम पॉइंट्स पे अप्लाई करने में हेल्प मिल सकती है. फॉर एग्जाम्पल, अगर आप यहाँ इस पॉइंट पर देखें विच इज द ओरिजिन व्हेन टाइम t इज 0. So at this point, the phase of this red one is 0 degree. When t is equal to 0, phase of red wave is 0. But at the same time, phase of the blue wave is 90 degree. So at this point, they have a phase difference of 90 degree. And this difference will remain same throughout the wave. चाहे इसकी फ्रीक्वेंसी कुछ भी हो, आप इस डिफरेंस को थ्रू आउट द वेव कंसीडर कर सकते हैं. सो दिस फेज डिफरेंस विल रिमेन सेम. एंड हियर वी कैन डिफाइन विच वन इज लीडिंग एंड विच वन इज लैगिंग. कि इनमें से लीड कौन कर रही है और लैग्स बिहाइंड कौन सी. नॉर्मली द वेव स्टार्टिंग फ्रॉम जीरो and increasing positively will be considered as reference wave. जो जीरो से स्टार्ट हो रही है, पॉजिटिव साइड पे बढ़ रही है, इसको रेफरेंस के तौर पर डिस्कस करेंगे. और जो सेकंड वेव होगी जो अदर देन जीरो स्टार्ट हो रही है, आप उसको डिफाइन कर सकते हैं कि आइदर इट इज लीडिंग और लैगिंग. सो हियर ब्लू वेव is leading the red wave by a phase difference of 90 degree. So we can say that this blue wave is leading the red wave by a phase difference of 90 degree. Same यही कुछ आप यहाँ नोट करेंगे. At this position, the phase of blue wave is pi or 180 degree. But for the red wave, that is 90 degree. Again, difference between these two waves at second point is also equal to 90 degree. So it will remain same throughout the time. फेज लैग एंड फेज लीड यहां जैसे आप इस डायग्राम में नोट कर सकते हैं. देयर आर टू डिफरेंट पॉइंट्स रेड एंड ब्लू एंड दे हैव फेज डिफरेंस ऑफ 90 डिग्री. सो दे हैव डिफरेंट पोजीशंस ऑन द वेव फॉर्म एज वेल. आप नोट कर सकते हैं कि इनकी पोजीशंस भी डिफरेंट है, दोनों पॉइंट्स की लोकेशन भी डिफरेंट है. सो विद द हेल्प ऑफ फेज वी कैन डिफाइन द लोकेशन ऑफ अ पॉइंट इन अ वेव फॉर्म. So here blue wave is leading the wave red wave by a phase difference of 90 degree. Now there are few points and some of them are called in phase points on the wave and some are called out phase points on the wave. So those points in which distance between them is equal to integral multiple of wavelength are called in phase points. कि ये वो पॉइंट्स होंगे जिनका दरमियानी डिस्टेंस इंटीग्रल मल्टीपल ऑफ वेवलेंथ की फॉर्म में हासिल होगा. फॉर एग्जांपल, इन दिस वेव देयर आर नंबर ऑफ पॉइंट्स but some of them have a difference or distance between them is equal to integral multiple of the wavelength. For example, if we compare this point D and the other point I, so distance between D and I is equal to one wavelength. So we can say that these points are in phase points. Similarly, distance between B and G So this distance is also equal to one wavelength. So they are called in phase points. And here difference between E and J, that is also equal to one wavelength. So they are called in phase points. So if distance between any two points is in the form of 0, lambda, 2 lambda, 3 lambda, or 4 lambda, then such points are called in phase points on a wave which have this condition 0 lambda, 2 lambda, 3 lambda, and 4 lambda. But out phase points are those which are separated by a distance equal to odd integral multiple of half wavelength, and they are called out phase points. यहाँ difference क्या है कि there should be an odd number, and number 2 half wavelength. But in case of in phase points, there is no difference between odd and even, जबकि यहाँ आपको odd number use करना होगा. For example, in this way, number of points are there. So if we compare A with A1, these points, then distance between A and A1 is one wavelength, so they are in phase. But if we compare A with B, so that is half wavelength. So distance between A and B is equal to half wavelength, so they are called out phase points. Similarly, if we compare A with B1, then distance between them is equal to 3 lambda by 2, because B to B1 is lambda, and from A to B lambda by 2. So sum of lambda plus lambda by 2 is equal to 3 lambda by 2. So if distance between 2 points is in the form of lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, then such points are called out phase points. So distance between them should be half wavelength with odd number as a multiple factor 1, 3, 5, 7. So such points are called out phase points. So this is difference between in phase points and out phase points. Thank you.